So we are going to fill KMnO4 in the burette and pipette out 10 ml of FAS in the clean conical flask and add 1 test tube of dilute sulfuric acid and titrate against KMnO4 taken the burette till we reach a permanent pale pink color. So when you start your titration, please rinse the burette with water. Then add KMnO4. KMnO4 is a colored solution, not a colorless solution. See the upper meniscus, not the lower meniscus. See the upper meniscus and try to fill KMnO4. So now as you rinse your burette, then using the funnel, you can add KMnO4. Don't add directly, use the funnel to add KMnO4 solution. Okay, so drop the make up to 0, drop the solution back into the reagent bottle and make up to 0 and see very carefully. The colored solution will be for the upper meniscus to 0. Make it to 0 and keep the bottle a little more far away so that it will not fall. So make it to 0 and keep it straight. Check whether there is any air gap. Because if the air gap is there, run the solution and again fill it. So there should not be any air gap in the bottom of the burette and no air gaps in the burette also at the bottom also. Once it is right, then you are ready for the titration. But you have to fill what I said already, 10 ml of FAS, 1 test tube full of dilute sulfuric acid. So rinse the conical flask, because and pipette out 10 ml of FAS solution, which is given already to you, a strength of 0.05 m FAS solution, that is called more salt solution. So as there is a mark, you will see a mark. So it touches the upper meniscus. See, it's a color solution, means it is going to be the lower meniscus. So catch hold the lower meniscus and try to fill in the conical flask. And then add dilute sulfuric acid, 1 test tube full of dilute sulfuric acid from the bench reagent. Even if you can add half a test tube also it's okay, but half a test tube of dilute sulfuric acid in the clean conical flask, that is a 10 ml of already added FAS solution is there. So keep the reagent bottle back there on the table and now gently try to focus on the color. That's what you're going to observe here carefully, and keep that burette stand straight in front of you and titrate and see the end point is what we're going to focus. The end point is the colorless to pale pink. So titration is ready and you're going to start the titration now, and as release the KMnO4 slowly dropwise and to find the colorless to pale pink, that is our target. So just focus on the change in the color. Just see that the permanent pale pink color remains. So permanent pale pink color remains in the conical flask as you get the end point. So as you're reaching near to the dark pink color, go for dropwise. Exactly, we are reaching to the permanent pale pink color. See, this is called, see, after I see that rotate the conical flask and just could see that it remains in a pale pink color. The pale pink color does not disappear, it remains. Once you get a pale pink color, stop adding, take your burette in your hand, your eye level, and check the upper meniscus so that the color is solution and note down the value. Let us assume today's titration what I did, you may get a value around the final burette what we started was initial was 0.0. Maybe the final today what I did, maybe I'll just write randomly 10.5. The first trial you got is 10.5. So don't again fill the burette to 0. Now second trial, you discard the solution, discard, again add 10 ml of FS, but start from where you stop. For example, the next trial will be from 10.5, right? And you may again do the trial, again 10 ml of FS, half a test tube of dilute sulfuric acid, titrate against KMnO4. You may get a pale pink color again, maybe around 21.0. Now again you got the value as 10.5. See, this is called CBR. When you get two values same, that is called concordant burette reading. When two values are same, it is called concordant burette reading. By chance you may not get in the second trial, you may get in the third trial CBR. So for example, you go to third trial, again you may get there, for example, if the second trial was 11.0, let us assume, the third trial you may get 10.5. You may stop the trial there, report to the examiner, and then they'll ask you to go for calculation. Then you can, please don't forget, for today what I told you, our concordant burette, just randomly I'm telling you it's not the true value. So it may be 10.5, I'll write 10.5 ml. Reporting is very important. So the burette, conical flask, endpoint, tabular column carries marks, 4 marks. Then you report the trial and focusing on the permanent pale pink color, you got 10.5 ml. I'm just randomly telling you that's not the value. The value keeps on changing. So for 10.5 ml we got. Now, this calculation part also is very much important. The calculation what I am discussing today is also very much important.